Hello, this is INE Foundation Lab 2, section 4.6 EIGRP. Configure EIGRP AS number 5 between 246 switch 1 and switch 2. Okay. Let's topology. We have switch 1, switch 2. Between these two switches we have Ethernet port channel 12, and switch 2 and R2 we have Ethernet 1.222, and between R2 and R4 we have Ethernet 1.24. These are in EIGRP 5, and between 4 and 6 there is Ethernet 1.46. This interface between 4 and 6 should be configured in EIGRP 5. Okay, you use a version of excuse me, use a version of EIGRP that supports IP version 6 within the same process. Okay, it says it should support IP version 6 within the same process. It means that we have to use EIGRP named mode. EIGRP can be configured in two modes. One is traditional or classic, the other one is named mode. Advertise loopback 0 of R2 and switch 2 into EIGRP using a network statement. It means that it is internal EIGRP metric. It should be 90. Loopback 0 of R2 and switch 2 should be configured by network statement. And it is redistribute the loopback 0 and interface VLAN 121 networks of switch 1 into EIGRP. Okay, it should be redistributed. It will become external, and external EIGRP has metric of 170. Okay, let's review EIGRP concept and go into configuration. Okay, this is EIGRP metrics. By default, car1 and car3 is set to 1. It is only car1 and car3 is elected or set to 1. This is bandwidth and delay. EIGRP by default only calculates bandwidth and delay. EIGRP's advanced distance vector protocol. It uses diffusion update algorithm rule. It used to be Cisco proprietary. Now it is open standard. It has administrative distance for internal 90, for external 170, and for summary 5. These are three different administrative distance of EIGRP. If you compare with network command, it will become 90. If you advertise it by redistribution, it will become external, and it will have 170 number cost. And for some other it is 5. It uses composite method. This is our composite method. It has protocol number of 88. It supports MD5 authentication, VLSM support, and root summarization. And it has very fast convergence over RIP, and it is available on time. Okay, EIGRP has 3 tables. One is neighbor table. We can see neighbor table by show IP EIGRP neighbors, and EIGRP topology table. We can see EIGRP topology table by show IP EIGRP topology, and for group routing table we can see it by show IP root EIGRP. Okay, this is EIGRP feasibility condition. I will explain it a little bit later. This is EIGRP packet type: hello, ACK, update, query and reply, and request. This is hello use multicast, and this unreliable. ACK always use unicast. So this is EIGRP step options. We have connected, summary, redistributed, receive only, and static. This is the EIGRP traditional configuration. We can configure it by rotate EIGRP AS number, network for advertising network, auto summary, neighbor, and clear IP. This is all our EIGRP command. And IP summary address, network subnet. This is for summarization. And the EIGRP root interface status. We have passive. If we do show IP EIGRP topology and we see passive, it means it is reachable and it's okay, it is working. And if we see active in show IP EIGRP topology, it means it is unreachable and there is no feasible successor. We have SIA. This is stuck inactive. This is when the condition when a route becomes unreachable and queries are not answered. If we query for the unreachable route and we don't receive update or we don't receive answer for that, it will become SIA. Passive interface, and 2,000 participate in the EIGRP, but network is advertisers. This is the EIGRP command, show IP EIGRP interface, EIGRP neighbor. This is for neighbor table, This is for EIGRP topology table, show IP EIGRP topology, and this is the debug commands. Okay, let me explain this EIGRP feasibility condition. Okay, this is our picture. We have 3 paths in here. One is from R1, the other one is from R2, and the other one is from R3. Okay, let me draw this. This is our path. Okay, this is from R1, from R2, and from R3. This is source, and this is destination. Okay, EIGRP feasible condition. Advertised distance or reported distance. This is metric from our neighbor to destination. In other words, how far the destination is away from our neighbor. This is advertised distance or reported distance. Okay, this is, let's see what is advertised distance or reported distance. This is the same. Okay, metric from our neighbor to destination. This is from first path. R1 is telling us that its metric to destination is 10. This is metric from R1 to destination is 10. Then it will become 10. For path 2 from R2, R2 is telling us that its advertised distance is 5. This is the metric from our neighbor. This is from this source. This is metric from our neighbor to destination. For path 2, this is 5. And from this path, from the 3, RT is telling that path from me to destination is 9. This is path from neighbor to destination. This is advertised distance. Another color. Okay, we have feasible distance. Feasible distance is our total metric from source to destination. Total metric or total distance to the destination, or metric on local water to destination. These are another from source to destination. This is feasible distance. Okay, here feasible distance for path from R1. This is source. The feasible distance will be advertised distance plus this path to our source. This is 5 plus 10. This will become 50. For path from R2, it will become 10. And for path from R3, it will become 109. This is this path. So this is 109. Feasible distance is cost from source to destination, or total cost, total path. Okay, then we have to choose successor and feasible successor. Successor is shortest method to destination. In other words, it is lowest feasible distance to destination, or it is lowest total method. The lowest total method or lowest feasible distance will become successor. The lowest feasible distance will become successor. From here, from this part from R1, this is 50, 10 and 109. The lowest one is 10. This 10 will become successor. This path is successor. Okay, for feasible successor. Okay, for a route to become feasible successor, it should follow this rule. The idea of that route that want to become successful, the idea of that route must be less than if the of successor. The idea of feasible successor, or the idea of that route that want to become successful, that route ADs must be less than if the of successor. What is FT of successor? FT is total metric. It should be less than total metric of our successor. Okay, our successor, our FT successor FT is 10. Currently, FT of successor is 10. Sure. And for a route to become feasible successor, its AD must be less than 10. Okay, from first path, or this first path AD is 10. 10 is not less than 10. 10 is equal. It is not eligible to become feasible successor. This is successor. 5 is less than. This is a successor. For second part, 9, it's AD. 9 is less than FT of successor. FT of successor is 10, and 9 is less than 10. Then this third part from R3 will become feasible successor. This is feasible successor. This part is feasible successor. This is EIGRP condition, feasibility condition, and this is this rule. It should follow this rule. Okay, now let's compare EIGRP traditional mode and named mode. In EIGRP named mode, we have address families. One address family for We have address family configuration mode, address family for interface configuration mode, this AF interface, and address family for topology configuration mode. This is EIGRP address families. So address configuration mode. In this format, we have to specify address family IPv4 or IPv6, unicast or multicast, and then automatic system number. Then we have address family for interface configuration mode. We type AF interface. Under this interface address family, in the interface configuration address family, we can specify authentication, passive interface, split horizon, summary address, and other parameters. And on the address family topology configuration mode, just we can go by topology based command. Under this topology address family configuration mode, we can specify variance, metric, redistribute is under here, redistribute and offset list and so on, auto summary and so on. In traditional EIGRP, it doesn't support IPv version 6 VRF. This is EIGRP limit mode. This address family configuration. I told you before. This is interface address family configuration mode. AF interface. This address family for IPv4 VRF. This address family for IPv6, and this is address family for IPv6 VRF. We can convert old EIGRP to traditional to named mode simply by this command: EIGRP update -CLI and AS number. This is, excuse me, virtual name. This is the name of virtual interface, virtual instance number. This is this virtual instance number for named mode. With instance name. Okay, let's come to EIGRP. We have to compare AS5 between 2, 5, 6, switch 1 and switch 2. Okay, on the here enable sharp interface brief. For two, I have two interfaces. This one and this is this one and this one. Okay, we have to advertise loop as we have R2 and switch to by network command. Loopbacks. Complete. EIGRP This is virtual instance name. Let's say EIGRP AS5. Address family IPv4 unicast. Then we have autonomous system number, and it should be 5. Under here we have this network. Choose one, this network. Zero and wildcard bits. It is 24 bit mask. Its wildcard should be this one, 0 and 255. Then we have to advertise loopback 0 by network command. Okay, now let's configure R4. Let's show the type section. R4. We have two interfaces, 2.4 and 1.4.6. These two. It should be 150, 124, should be 1.4.6, and we don't have loop back. Okay, and R6, Web 1 interface, and no loopback. Okay, R6, one four six. This is what this network. Okay, and for switch 1, we have to redistribute it with passive and interface VLAN. Okay, now switch 1. We have this input channel and okay, I only have this port channel. Then I have to redistribute with passive and interbilan 121. These two should be redistributed into EIGRP. Okay, let me create a route map. Route map. Connected. These are connected into EIGRP and permit. I will match interface loopback 0 and match interface VLAN 121. Exit. uh, for the distribution I have to go into topology base address family. Go to EIGRP. Then this is I prefer this family. Then I have to go on to topology base. Then I have to distribute connected route map and R route map name. And last device switch to where I have to advertise the passio of switch to by network command. This is the passio into network command. Okay, I have this in network and we have this and we have three network. After the three network. Okay, one is this one. Yes, just 32. Then we have this network. And this one. Okay, now let's verify. session, and we don't want it. Show IP EIGRP neighbor. This is EIGRP transitional show command. For name show command, I can use this one. Show EIGRP. Then add this family. Then IP4. Unicast. Turn system number. Then number. This is new command for يجب نعمل move. On switch one I have one. Let's verify. One port channel on switch one. Then on switch two I have two. On R2 we have two. R4 I have two. On R3 I have one. Okay, now let's see. Show IP EIGRP. This is neighbor table. This is EIGRP neighbor table. We have neighbor. We have topology table. Show IP EIGRP topology. These are topology table. Yeah. All of passive. This is good. So we have one successor, and our feasible distance is this one. This is why I connected. If I see this, this is all connected. And 222 is not connected, and this is our feasible distance is this one. This is our feasible distance, and this is our advertised distance, AD. This is our topology table. For global, I can show IP dot EIGRP. This is our global. Okay, we have here You have redistributed loopback 0 and interval behind 121 of switch 1. It should become external EIGRP 170. This is loopback of switch 1, 170, and this is our interface 121. This is external. Okay, this was EIGRP. I hope you have enjoyed this video, and thank you for viewing.